Okay, so now we're going to talk about quantum numbers, what they are, how you get them, that kind of thing. So the first thing we're going to talk about is your energy levels, okay? So the first thing we have here is this variable n equaling 1. And n is whatever energy level you're talking about. So in this case, n equals 1 is the first energy level, okay? And you guys know what shape can be on the first energy level. Yeah, it's that S, right? It's the S. So first energy level only has the S, and then each of these orbitals can only hold 2 electrons, right? So first energy level only has 2 electrons, like we've been told before, all right? So now we're just gonna kind of go through each of the energy levels. Here's the second one, n equals 2. This is the second energy level. It contains 2 types of orbitals, S and P, which we know, right? S has the 2 from before we talked about, but P has 3 suborbitals, and each of those can hold 2 electrons, giving us a total of 6, right? And this is what we talked about before, right? We know what to do. We would draw our little lines here and our whatever, 3P or 2P, whatever it happens to be, all right? Those 3 suborbitals can be divided into X, Y, and Z, and those were the dumbbell-shaped ones. So overall, n equals 2 can hold how many electrons? Because it has S and P. Yeah, exactly. It's going to have 8. And everybody's okay with that, right? Okay, that's kind of a review. Okay, when n equals 3, third energy level, now we have the D's. All right, D has 5 suborbitals. Each one can hold 2, so now we have a total of 10 more, all right? So between the S, the P, and the D, how many now can we hold? 18. Yeah, now we can have 18, exactly. All right, so we're gonna have 18 electrons. And last energy level we're gonna really talk about, because now we have the F's, would be the fourth energy level. So we have S, P, D, and F. We just had 18, right? Now we have this F's, which have 7 suborbitals. 6, 7. Each of those can have 2. Extra 14. What's the total now? 32. 32, yeah. So the fourth energy level can have up to 32 electrons. All right? Okay, so that's kind of the basics of each energy level. To figure out what the quantum numbers actually are, it's kind of like the coordinates for each electron, all right? So you can do it for any electron on your atom. We're always gonna do it just for the last one that we draw, all right? Just to keep it constant. That's how we're gonna do it. So quantum numbers are like coordinates, which tell you where an electron is likely to be found. In this unit, we'll always find the quantum number for the last electron added. And you need 4 quantum numbers per electron. So like in math, when you're doing the x and the y-axis, you have 2 numbers, right? Because atoms are 3-dimensional, and because of the way that the electrons move, we actually need to have 4 different numbers for this, all right? Okay, so n is the first quantum number, which we talked about. It's the energy level, right? So n is called the principal quantum number. This is the energy level for the last electron. You just use the number, all right? So if n equals 1, this means the electron is on the first energy level, and n equals 1 means it has to be an S, right? But let's talk about oxygen, since that's the example we're gonna go through for this whole thing. What's oxygen's electron configuration? We don't have to do a shortcut, it's pretty short. 1s2, 2s2, 2p what? 2p4, okay. So at the end of this, we're looking at that 2p4, right? All right. And if we were looking at the orbital diagram of just the p's right here, it would be 2p, then 1, 2, 3, 4. You see how I drew that arrow last? That's the one we're going to be talking about while we're doing quantum numbers, okay? So that's how we're going to tell. You can find the quantum numbers for all of them, but we just are going to do the last one, all right? It's just a choice we're going to make, all right? So if you're looking at this arrow, you're going to use information from all of this. What is the energy level? It's the 2, right? The 2 is the energy level. So n equals 2. for this. So our first quantum number is going to be 2 because it goes n and then other stuff. All right, so that's the first number. Not difficult, right? First one we got. All right, 3 more to go. All right. Okay, so the next one is this italicized lowercase l. That's what it's supposed to look like, okay? And it's the angular momentum quantum number. That's kind of the definition of it, but you just have to worry about how to figure out what the number is for it. This represents the orbital. So what are the orbitals? Well, your options are S, P, D, and F, right? So starting with S, its number is 0, and then you just count like a number line. So you have S is 0, P is 1, D is 2. I get an F for formatting. Right? All right. F equals 3 because it got a little messed up there. So O's electron configuration: 1s2, 2s2, 2p4. Right? Okay. Which of the last arrow that we drew? Right. So we have to look at the orbital diagram. Here's our 2p. Right. Up, 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 down. Oops, that down one's over here. It's got a little messed up. All right. So what orbital would it be? It's a p, right? So what number would it be? 1. Yeah, exactly. So n, we already knew that. It was 2. And then our L is a 1. Okay? So we have 2, comma, 1, comma, some other stuff. All right, does that make sense? Okay. And again, you're just telling me all about the electrons. So it's on the second energy level, and it's a p. That's what these two numbers told us. Let's keep going. Okay, M sub L. It's the letter M and the subscript of that italicized lowercase l. This is the magnetic quantum number. Your options for this are plus or minus L, whatever you got for L. So that was 1, right? So plus or minus 1, you just think of it as like a number line. So minus 1, plus 1, and then all the numbers that come in between. And we can only use whole integers, okay? So the only number in between would be 0. So these are your options for it, okay? If L equaled 2, it would go from -2 all the way to +2. So again, it just depends, all right? All right, so to figure that out, we need the orbital diagram. All right, we have this again. All right, orbital diagram. 2s up, down. 2p up, 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 down, right? And that's the last one that I drew, right? The one over there. Okay, now check this out. You don't even really need to know that it's the plus or minus L, because take a look at the P's over there. You see how there's 3 of them? 1, 2, and 3. No matter what it is, the middle one is always going to be 0, all right? So this is going to be 0, and then you just build your number line from there, okay? So if you're going 1 to the left, it's going to be -1. If you're going to the right, it's going to be +1. And then that's pretty much it. There's your number line. That's what we did up here. The whole reason we did this was for that. What do you think, what would you need 5 for? Yeah, the D's, right? The D's you'd need 5. What would you need 7 for? The F's, right? So that would be plus or minus 3, all right? So that's how it's all related. But again, you don't even need to think of this if you just remember that in the middle it's 0, and then you just count out either way, okay? So what's our quantum number gonna be, M sub L? Out of these 3 options, which one are we gonna pick? -1, right? Because again, we're only talking about the last arrow that you drew, which was this down arrow over here. So yeah, it's gonna be in the position of -1, all right? And the other ones are still second energy level, and it's a P. So now we have 2, comma 1, comma -1, and then something else. Good? Okay. All right, so that's that one. The last one. Okay, so you can just look at your orbital diagram from above. This is M sub S. It's the spin quantum number. And this tells us whether the electron is spinning clockwise or counterclockwise. And the way we do this is if it's plus 1/2, that means the arrow is up. And if it's negative 1/2, that means the arrow is down, okay? So we just look at our orbital diagram from above. I'm just gonna draw that one part of it, which was 2p up, 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 and then down, right? And we were looking at that last one I drew. So because it's a down arrow, the m sub s is just negative 1/2. Those are the only options for it, all right? So then it's on the second energy level. It's a p, which is a 1. M sub l, that was the negative 1 because it's over there, and then negative 1/2. So those are our 4 quantum numbers. 2, 1, negative 1, negative 1/2. And that's it, all right? It seems like a lot. It seems like a lot of steps, but if you just kind of follow along with each part, it's not that bad, all right? Do you guys have any questions with it? We are going to go over a lot of examples because it will help the more you see it, all right?